All right, lesson 20, combining like terms, part 1. We're on page 147. The learning goal says, let's see how we can tell that expressions are equivalent. And the I can statements are, I can figure out whether two expressions are equivalent to each other. And when possible, I can write an equivalent expression that has fewer terms. So number 20.1, explain why each statement is true. 5 plus 2 plus 3 equals 5 plus parentheses 2 plus 3. So here, order of operations tells me I do this part first. 5 plus 2 is 7. 7 plus 3 is 10. Here, 2 plus 3 is 5. 5 plus 5 is 10. Okay, so with addition and with multiplication, the order of the problem doesn't matter. So if I have all multiply or if I have all add, the order doesn't matter. Okay, number 2, 9a is equivalent to 11a minus 2a. Well, if you think like a for apples, if I have 11 apples and I minus 2 apples, I have 9 apples. So that's how that works. Okay, 7a plus 4 minus 2a is equivalent to 7a plus negative 2a plus 4. So we can move the order of the problem around as long as we keep the signs with the same part. So all they did here is they took the minus 2a and they put it in front of the 4, okay? And then AA minus parentheses 8a minus 8 is equivalent to 8. So if I notice here, there's a minus in front of the parentheses. So yesterday we talked about using the distributive property. We can take this minus and distribute it to the minus 8 and to the negative 8. So 8a minus 8a, and then a minus times a minus is a positive 8. So AA minus 8, a goes away, and I'm just left with positive 8. All right, 20.2. Diego and Jada are both trying to write an expression with fewer terms that is equivalent to 7a plus 5b minus 3a plus 4b. Jada thinks 10a plus 1b is equivalent. Diego thinks 4a minus 9b is equivalent. So, number 1, we can show expressions that are equivalent by writing out all the variables. Explain why the expression on each row is equivalent to the expression on the row before it. All right, so they take the 7a, the 5b, the negative 3a, and the 4b, and they write them all out. So they have 7a's, they have 5b's, they have 3a's, minus 3a's, and then they have 4b's. So then they break this 7a up into 4a's and 3a's. Because if you notice here, we have a minus 3a. So then they take this and they move it here so that these two are right next to each other, so they're going to cancel each other out. So then we have 4a, 5b, 4b. So then we have 4a still, and then they put the b's next to each other, and then they combine them all together and get 4a plus 9b. But that's a lot of a's and b's you have to write out, right? So you can think of it as just, let's look at all the a's. So we have 7a here, and we have minus 3a here. We have to keep the sign that's in front of it. So 7 apples minus 3 apples is going to give me 4 apples, okay? And then I can look at the b's, 5b and 4b. If I have 5 balloons and I add 4 balloons, I have 9 balloons now. So I have 4a plus 9b. That's another way to do it without writing all of the a's and b's. And there they show it to you. They break it up a little differently. They even do it more work than I think is necessary, but you do what is easiest for you. Okay? All right, moving on. Replace each question mark with an expression that will make the left side equal to the right side. Well, 6x plus what is going to give me 10x? Well, 6 plus 10 is 4, so 6x plus 4x is going to give me 10x. Well, 6x plus what gives me 2x? Well, we're starting with a bigger number and we're getting to a smaller number, so it's going to be negative. It's going to be negative 4x. 6x plus what equals negative 10x? That's going to be negative 16x. 6x plus what equals 0? Well, negative 6x. And 6x plus what equals 10? So this one's a little trickier because you got to get rid of the x's. So we go negative 6x, that will give me to 0, right? Plus 10. So it's going to have 2 parts to it. Okay? Same thing, set B, except for now they're subtraction problems. All right? So looking at the summary, there are many ways to write equivalent expressions that look very different from each other. We have several tools to find out if 2 expressions are equivalent. 2 expressions are definitely not equivalent if they have different values when we substitute the same number for the variable. For example, 2 times the quantity of negative 3 plus x plus 8 and 2x plus 5 are not equivalent because when x equals 1, the first expression is 4 and the second expression is 7. If two expressions are equal for many different values we substitute for the variable, then the expressions may be equivalent, but we don't know for sure. It is impossible to compare the two expressions for all values. To know for sure, we use properties of operations. For example, 2 times the quantity of negative 3 plus x plus 8 is equivalent to 2x plus 2 because we use the distributive property to get rid of the parentheses. So 2 times 3 is negative 6. 2 times x is 2x. So we have negative 6 plus 2x plus 8. Then we can move the numbers around as long as we have the same. As long as we keep the same signs with them, we can move them around. So notice the minus 6 always stays with the negative always stays with the 6. So we move the negative 6 and the 8 next to each other. So negative 6 plus 8 is 2. So we have 2x plus 2. All right, so looking at your assignment today, it looks like we're doing number 1. So you're just answering, are they equivalent or are they not? True or false? And then number 2, you're selecting all the expressions that are equal to 3x plus 5. So like number 2. So you're selecting all the ones that are equal to 3x plus 5 after we combine our like terms. Remember, if you have any questions, you can always send me an email. Thanks.